Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the Event Horizon here on Astronomy.fm radio. That means it is another Friday evening, August the 2nd, 2019, 9 o'clock in the evening for those of us here in the eastern portion of North America. Universal Time puts it at August the 3rd, Saturday morning, 1 o'clock in the morning, again, 2019, 9 o'clock in the evening for us. So sun's just starting to set, getting dark out there, and new moon weekend, or new moon, yeah, this is like a new moon weekend this weekend. Well, good for some deep sky observing, but we should get a crescent coming up pretty soon.
It's already peeking its way through the crescent moon. Good evening, everybody. It's me, Nick Yvette's 2 Echo Zero, Lima Uniform November. Okay, I've got a little bit of a beef. What else is new? Sky and Telescope, you deserve a very heavy slapping for this. They had a thing called a black moon.
Black supermoon, I think, even.
Well, the thing is, it is 2 new moons in the same month.
Oh, well, yeah, that's true. But I think it was also a supermoon, too, isn't it?
I don't know about the super. What is this supermoon? You mean the energy of the Earth, Moon, and Sun system?
Supermoon means closest in its orbit, so it appears to be biggest at that time.
Supermoon is an astrological term, Marty.
Supermoon, no, stupid is an astrological term.
Supermoon was coined back in 1976 by a U.S. astrologer. It's been picked up by the media because it's snappy. It's a clickable. It's clickbait.
They didn't have internet back then.
Believe me, if you Google the term supermoon, and let's just, I'm just going to do that just for the heck of it. It is nothing to do with astronomy.
They didn't have Google back in the 70s either.
Supermoon was, I think it's a chap called Norman, I can't remember Norman's last name, but it was 1976. Let me just put this in a slightly different way, in a different question format. Who coined it? Richard Nolly, I correct myself. Now, they're now calling him an astronomer. Well, he was actually an astrologer. He coined the term over 30 years ago, and it really did not gain popularity until about March the 19th, 2011. And to be honest, it's about as scientific as saying that there is a black moon tonight. Well, it isn't a black moon. What they're actually talking about is when you have 2 new moons in the same month. Nothing to do with black moons at all. Thank you very much, their Black Project. He's put a link in there. And, of course, there's also a link in there about the first Atlas Centaur launch. So,
well, if you looked at it, there's no light on our side of the moon, except for Earth light.
So it's a new moon.
It's a new moon, yes.
But it is not a black moon.
No, because
1979 in Dell Horoscope magazine. That's when it was used by astrologer Richard Nolly. And arbitrarily defined. Okay, so let me go into Wikipedia, because this is one article I have actually verified the details. Dell Horoscope magazine arbitrarily defined it as a new or full moon which occurs when the moon is at near or within 90% of its closest approach to the Earth in a given orbit at perigee. Now, we astronomers use the term either perigee seismology or aporigee seismology. So, and the other clickbait term for the apology version is a micromoon. And Black Projects is joking, having a good joke with us. It's only a supermoon when it's got its cape on. I like that one. But anyway, it can happen at new or full moon as long as the moon is at perigee. That's when you have the so-called supermoon. They're not supermoons. It's nothing to do with astrology, but unfortunately is an astrological term back from 1979. So there you go. Supermoons has nothing really to do with astronomy, apart from the fact that it's the press overhype it. It's like me sending you an email, Marty, saying the Mars will be as big as the full moon tonight. We all know what that means. It's a hoax.
And as I say, anyway, Mars is always bigger than the moon.
Only if you're at Mars.
It's a planet.
Yeah. Anyway, the thing is, though, I really, really dislike some of these really daft terms. Now, I can understand describing a lunar eclipse as a blood moon because it does turn a very nice coppery red color. It is a accurate,
but it's not astronomy.
It's not. It's an easy description to make. But
so during a lunar eclipse, we could call it a Mars moon. How about that?
There's an idea.
Yeah.
But
the idea.
Marty says we should call it a Mars moon. But Martian moons we know are rotten in the core. We know at least one moon is thought to be as rotten as a overripe potato. It's been left out in the sun for too long.
I got a bag full of those on the floor in my kitchen.
Yep. But anyway, so calling two new moons in the same month a black moon is hype.
Come up with a better phrase then. It's like, come up with something that would be better than a black moon. Then we'll use that.
Mars moon, a Mars bar moon. Yeah, I can Mars bar moon any day. That'll keep me busy for work, rest, and play.
You call them dark chocolate moon.
You have to be British to understand that one.
It could be a dark chocolate moon. How about that?
But anyway, I don't like inaccurate descriptions. The only reason I don't really get wound up about a blood moon because it does kind of describe the color of the moon, which is fair enough. And we all know that we can't see the new moon because that's always been that way. But
we really shouldn't call it a new moon either because the moon is like 4+ billion years old. So calling it a new moon is really inaccurate.
Yeah, but it's just a way to describe it compared.
It's more like it's more like an astrology term.
No, not really.
New moon, it's not moon. It's not new. It's not accurate. Scientifically accurate.
It's at a
anyway.
new point in its phase. How's about that?
Yeah.
But anyway, as I say, black moon it's new moons happen every 29.5 days. Our months are a little bit longer than this, so sometimes we get two. Sometimes we get 2 full moons in a month. I think that is where the term "once in a blue moon" because it isn't a regular occurrence. So, as I say, I don't like it. It's one of those things. So, if a new moon happens near the beginning of a calendar month, then the next one will happen before it's over. There's no science there. It's just an artifact of how we keep time.
Well, anyways,
in a calendar anyway.
The moon tonight is like 5.4% lit up. So that's a nice thin crescent, 2 days old. So get out there and look for it just after the sun goes down towards the west. It should be really nice thin crescent if you got some clear skies. This is one of the phases I really like looking at the moon in. From just my eye, no telescopes.
Yeah, the nice thing about the lunar phases is you get to see the lunar surface under different lighting conditions.
Yeah.
Everybody bitches, oh, full moon, everything's blasted out. Well, not really. You can still see the mare, and you can still see some color graduations on the lunar surface. You do need, it is always a good idea at that particular point to use a filter, because it'll help cut down the amount of light, and it'll let you see a lot more. But you can still do a lot of stuff. You can hunt around the edges of the mare, and you can certainly look at the larger rayed craters. And of course, as the moon wanes, the terminator is moving, and it changes how you see features. Sometimes it'll highlight perhaps the rim of a crater, or a peak in the middle of the crater, or perhaps a string of lunar peaks. So it's always something different you can see with the moon and of course the real fun thing is to try and catch it at its absolute thinnest. I think there's quite a few astronomers that try to outdo each other, trying to image the moon as thin a crescent as possible. Sometimes it's barely detectable as a glimmer of light, and that's what they're trying to capture. Of course, you can't really see much, but it's just the fun of trying to stretch your equipment and to see how close to it still being the named new moon as it is. But as I say, I don't see the point in calling this a black moon. I don't agree with micro moons. I don't agree with super moons.
All right, I got the ultimate name. I got the ultimate name for it. We're going to call it from now on the goth moon, because it's just a phase that it's going through.
That could get interesting. I know a few goths. I'll try that one and see what they try that one on them and see what they say.
There you go. It's official now.
Yeah. Well, anyway.
Gotta say hi to everybody in our chat room tonight. We've got you and me in the chat room. We've got Black Project, Glenn, Starstorm, and Optronics. And, of course, we're open for more people to come on over. Go to the homepage, astronomy.fm, and look down near the bottom. You'll see how to get into our chat room, which we're looking at as we're broadcasting live right now.
And, of course, people are in the chat room and they're asking questions and they're talking.
We've got a question from our chat room.
Yes, we do. Does the moon go in front of the sun every month?
No, because if it did, we would have a solar eclipse once a month, but the moon's orbit is tilted about 5 degrees to the ecliptic. The ecliptic line is, from our point of view, that's the line that in space that the sun goes around on, and the moon is said its orbit is tilted 5 degrees to that. So twice a month, the moon is on the ecliptic. But if the sun is not in that same spot, we don't have an eclipse, whether a lunar or a solar eclipse. So it's just kind of a random thing. When the moon happens to go on the ecliptic and the sun is at the same position, then we get an eclipse. But most of the time, no, we don't get an eclipse every month.
We get annual eclipses as well as the regular eclipses.
So to continue on, there's no total eclipse every month, and there's no partial eclipse every month either.
Aren't we lucky? Just think of the doom and gloom that would be about. People still believe that the moon eclipsing the sun will bring dire consequences to Earth. Yeah, grow up and get real.
There you go. Glenn says, but there is one in space. Yes, that's true. You could be always into the shadow of the moon. And so basically, if you're looking at the moon, anywhere it's dark on the moon, from that position, the sun is behind the moon. And if you're far enough away, you could get it so that the sun and you and the moon would line up just right. And, you would see an eclipse of the sun all the way around the moon.
Okay, so we dealt with black moons. So let's go look at Changi 3.
Okay, let's go to the moon. Is that Changi 3 or 4? Which one's on the moon?
It's Changi 3 with this lander and its companion rover U2. So there we go. Thank you to physics.org. Some cracking good stories. Even though the rover's engine failed after a short time, the mission's camera systems have captured hundreds of images. Thanks to the hard work of Emily Lakawada at the Planetary Society, who wrestled with a somewhat cumbersome Chinese website. My gosh. I swear I haven't been drinking this evening. And I stitched some of the images together so we can get a first-hand look at what Chang'e 3 and U2 were up to. So there's a lovely 360 panoramic image of the rover and part of the lander. And there's some nice pictures underneath which go on to show what we're seeing.
How long it was supposed to be active? Now they're calling it engines. Must be really a motor.
Yeah.
Engine was just a fuel source, like combustion type, where a motor would be more like electric motor. So was there any, do you recall if it was supposed to last longer than a short time, or that was just part of its schedule to last a short time? Like
it was supposed to be short-lived. It was
so
to be a technology demonstrator.
So it had basically batteries, and then when the batteries died, that was it. Instead of solar panels to recharge them or anything like that, I take it. Okay.
Well, as I say, I'm going deeper into the report, and no worry, Glenn. We love you that you ask us questions. It hasn't been an easy few lunar months for the rover. It's had problems positioning its solar panels in March whilst exploring the lunar surface. But that said, reports are emerging that the rover is still alive. Along with the reports came a new panorama released in time for the Moon Festival in China. As you can see in the video above, the panorama shows the lander, the tracks of the rover in the Mare Imbrium. The duo landed on the Moon on December the 14th, 2013, with the rover on top, and then U2 then drove on its 6 wheels onto the surface only about 7 hours after the touchdown happened.
So maybe it was a fuel type of engine, and then it's still running off of batteries and solar power. Then I don't know.
But as I say, it's an accomplishment for China. It's only the third nation to make a soft landing on the Moon, after the Soviet Union and the United States. It's the first one to touch down in more than a generation, as other lunar programs such as LRO, which still remains in operation above, are focused on orbiters. So, and as I say, and of course, according to the Twitter account UF Satcom, the X-band carrier signal was strongly audible from the Earth. Now, that was, so Chang'e 3 was September 2014. We've had another lander that's even demonstrated even more technology on the far side of the Moon. They now said this: we were getting signals. They were using a satellite in a predetermined orbit to pass the signals to Earth. There was a camera on the satellite. If you had an amateur radio license and you had a decent enough array, you could actually send commands to the said satellite to take a picture. The only country that's actually gone that far to let civilians all around the world access and send commands has been China so far.
Did they actually really write a predetermined orbit? Because, like, as opposed to one just randomly circling anywhere?
Well, no, it's in a predetermined spot to allow the lander to talk back from the far side of the Moon. Because radio signals won't go through the Moon. That was the whole thing, because I believe one of the original plans was for an Apollo mission to the far side. Now, obviously, the big thing about that is you have no communication. Once it crosses onto the far side of the Moon, you're out of contact. The only way you're going to have contact is every time the command module comes around on its orbit. And
unless you had a really
predetermined spot, you would
then
have
long
two
wire.
communications. Sorry, what was that, Marty?
Unless you have a really long wire.
No, the type of that doesn't work at the frequencies that they would be deploying. They're not using shortwave. They're using line of sight transmission.
I mean a wire from the far side to the near side, reaching two different probes.
No, that's
it could
not
work.
Feasible. It could work, but it would wait. But as I say, it is the fact that they have established a communication satellite for Changi 4 to speak to the lander, the rover there, and to talk back to Earth. These are all at the end of the day, these are all technology demonstrators. This is a concept even NASA decided that not going to bother with. But I guess some people are now probably kicking themselves because it's now been done. It was written off as being too difficult previously. Obviously, it's not quite right, Starstorm. I think our mission control is suggesting something. So let me just quickly move back. I'm just going to pull up mission control. Here we go. Oh, yeah. Marty, you're working on a restoration project, I understand.
I am working on a restoration project, yes. It's called the McMath-Hulbert Solar Observatory. It's actually a complex of 3 main telescopes. One started out like basically a small reflector, became a refractor with a hydrogen alpha filter in it. Then the second one, the main mirror in the second one, I think it was about 18 inches, 16 inches, something like that, with a focal length of about 50 feet. And it's in a building that basically the whole building is the telescope. It's made to collect sunlight and break it up from a diffraction grating into a spectrum. And then having a small slit over different parts of the spectrum, they would scan the sun and be able to observe and photograph the sun in different frequencies like hydrogen alpha or calcium light or sodium light and so forth.
Have you got it?
Yeah, it was in mission control, but let me pop back in here.
Yep.
See. And we're going into our chat room. There we go. And the third one, focal length is about 100 feet. Again, about a 16-inch mirror. So it kind of bounces up and down the tower. And then it gets deflected into a vacuum chamber. And inside the vacuum chamber is another spectral grating. And they were doing a couple things with that spectrum. They were electronically measuring it, and they were also photographing the solar spectrum, as well as measuring its intensity at different wavelengths and stuff like that, too. So that's my project, restoring that. Right now, the smallest dome one has a wooden roof that was put on around 1930, so it needs a lot of work. So we've been stripping off the old coating. It was actually covered with canvas, which is painted, covered with styrofoam and painted again. And it was a wooden dome. So we've been tearing it all off and trying to find where the big holes are and plug them up. And we've got a lot of projects to do out there.
Good luck with that, Marty.
Mm-hmm. It's fun.
Yep. Cephids are back in the news.
What's in the news?
Cephids. Yes.
Variable stars.
Yes. Now, what it is, the link is in the chat room. They're using the data from Cephids, to create a 3D model of the Milky Way galaxy. Okay, so this is actually a very much up-to-date story. A team of researchers at the University of Warsaw has created the most accurate 3D model of the Milky Way galaxy to date. Their paper, published in the journal Science, the group explains how they use measurements from a special group of pulsating stars to create the map. Most people imagine, obviously, the Milky Way is a flat spiral. That is the way it's been shown in school textbooks for years. I remember having it described to me as a pair of fried eggs slapped together back to back. The yolks obviously being the center of the galaxy. In more recent times, however, scientists have discovered that our galaxy is not flat at all. I really do like this description. It's more like a wobbly, uncooked piece of crust that's been tossed in the air. In this new effort, yes, it isn't it? Something almost out of Doctor Who. Yes. So anyway, in this new effort, the researchers have found our galaxy is even more wobbly than expected. That was a very good precursor there. Thank you, Starstorm. Wibbly wobbly timey wimey. Anyway, so to create the map, they used data from the optical gravitational lensing experiment, a long-time sky survey project based at the University of Warsaw. More specifically, they wanted the data regarding the Cephids, which are a very unique type of pulsing star. They were useful to the research because they pulse with regularity and brightness, which means their true brightness can be calculated. And compared to the brightness of them seen from here on Earth, doing that allows for very accurate measurements as to how far away they are from us. They used data from 2,431 Cephids collected over 6 years. Putting them all into a map together, the researchers were able to produce a 3D representation of the Milky Way, at least from the perspective of Cephids. Okay, Glenn. I think, Glenn, you've got a bacon pizza tonight. So this is actually the first model to be built using direct measurements of star distances. The really great thing about it is it was the fact that the Cephids allowed us to realize that the previously thought nebula that was Andromeda was in fact a galaxy in its own right. This is going back to Hubble's work, and I believe that was with the Palomar telescope, one of the most he did a lot of his work with. And I think he was also at a few of the other big scopes. So, of course, looking at it, looking at the map of this universe now, as from the point of view of a Cephid, it is a very uneven place. In fact, this is credit goes for the plot to J. Squalron / Ogle, and the Milky Way panorama was by Serge Bernier. But you know what? It is really, really nice to see these lovely little surprises. No worries about it, Glenn. Bring in your sci-fi comments are welcome. Let me. Oh, yes, Dan Dale would have loved it. But anyway, when you think about the distribution of young stars, in this case Cephids in the disk, it is very much, I suppose you might describe it slightly as a slight butterfly effect. I wonder if I can capture the image. Here we go. Let's put that image into the chat room.
Right. Try that. Yeah, I tried the image and I just got to the main website. Yeah. So let's see if this one will go through.
Yeah, it's come up nicely. Okay. So now you can see what I mean. That is an image of the Milky Way as inferred from the Cephids.
Slightly different from
the traditional view of the
from the article. The image of the Milky Way in the article has got kind of the general Milky Way picture in an oval shape, and the Cepheid arrows plotted over it. Well, you can see, you got to remember that the right-hand edge and the left-hand edge should be attached together. So that means we're basically seeing only one edge of the Milky Way, and it's basically kind of bulky, whereas the central plane of the picture is fairly flat, and then a slight bulge in the middle of Cepheid variables also. So it doesn't actually. So it basically shows us the outer edge opposite away from the core of the Milky Way. So that's where that's basically kind of bulging. So it doesn't have the higher up on one side and the down low on the left side, because you got to remember, you got to wrap this image around so the right edge and the left image attach to each other. So I don't see that. Go ahead.
In fact, there's a very nice video. If you scroll down from where we got the pictures that we're looking at, there's a brightness versus time plot video, and then there was one below it showing the 3D structure of the Milky Way based on over 2,000 Cepheids with precisely measured distances. Mm-hmm. So that kind of gives you an idea of what it looks like.
Mm-hmm. So a new way of sort of helping to image where some things are in the Milky Way galaxy.
Yeah, but it's really changed the perception. To be honest, we have this one perception, the fried egg perception, and with everything apart from the core being a bulge. This is completely changing that feeling and that idea, I think.
I think now it's kind of more like cracking two eggs at the same time, where the yolks kind of blend together, but not completely, so they're still elongated.
And of course, Black Project is putting some excellent links in about the Milky Way feeling the effects of an ancient encounter, and our ongoing rendezvous with the Large Magellanic Cloud.
Mm-hmm.
And they're saying that one of the things he's pointing out is that the Milky Way could crash into another galaxy billions of years earlier than it's been predicted.
Oh, Andromeda.
It's interesting stuff.
Yep.
Well, no, this is actually the Large Magellanic. We know that they're going to interact with Andromeda. We have done on a few occasions already. Mm-hmm. But nothing as drastic as really happened from we're getting closer to it. And as I say, let me have a look at this article that
right.
Yeah, we're
you do that, and I'll explain something amazing that's happening right now. What's amazing is we're halfway through our program for tonight, and you're listening to Astronomy.fm. This is the Event Horizon, where we've been live for the first half hour, live for the second half hour. So come on over and join us in our chat room if you'd like to. If you have any questions for us, please feel free to ask them. And we've got another half hour of live programming here on Astronomy.fm radio, the Event Horizon.
Now, the thing is, before everybody gets their knickers in a twist over the Milky Way crashing into another galaxy, well, they're saying between 1 and 4 billion years from now. So we ain't going to be here. It doesn't bother me too.
I want to see it, in fact. I want to be there when it happens.
There's only one way to do that, Marty. You need to borrow a Type 40 TT capsule.
There you go. TARDIS.
Yeah.
There you go.
But as I say, and we know for a fact that so far, Stephen Hawking has proven that time travel does not exist.
I know. He said that 100 years ago.
No, because he held a party for the first time traveler.
That's right.
And nobody turned up for it.
That's right.
Well, certainly from the future, anyway.
That could be
could
be just his personality. You never know.
I don't know. If I'd have got an invite to go to one of his parties, I'd have been there. Apparently, they're actually quite good, and of course, you would get to rub shoulders with the likes of Susskind and all the great theorists of the current age. The other thing, of course, is as far as most people are concerned, the Large Magellanic Cloud is actually heading in an opposite direction from us. But some of the recent observations of the LMC have revealed it has more mass than previously thought. The Marius Katun, I hope I got that right, at Durham University's Institute for Computational Cosmology, there's a word you don't want to speak when you're drunk, has revealed that it has more mass than thought. They did a whole bunch of supercomputer simulations and making adjustments in mass, velocity, and other measures. In the end, they predicted that within several 100 million years, the Magellanic Cloud would turn around and head straight for the center of the Milky Way. Is it going to impact me? note, because we'll be long gone. The Earth will be long gone. So will most of our solar system will be long gone. So we won't be around to see it. But it will be interesting, I'm sure, whoever's there to see. Hi, Red Shirt. I'm glad you could make it today. Plagiarized Sagan, I know. But there's some interesting stuff there. And there's another one about ripples that we can see. So thank you, Black Projects. We really do appreciate the links you gave us. They're really good. Thank you.
Well, we've talked about astronomers and astrologers, and we haven't talked about cosmology. And well, you said, but you know how what you call the people that think that the universe is just a really beautiful place? Those are called cosmetologists.
Okay, so pulsating stars. Gee, we're having a fun day.
The stars. How about let's do this radio astronomy thing?
Sure.
There's a convention this week in Green Bank, West Virginia, where they have the big Green Bank telescope, radio telescope, a group called the Society of Amateur Radio Astronomers. Let me put that up into our chat room. Nicknamed Sarah. Yeah. And they're having their big conference this week. See by the Green Bank Telescope. So if you're really interested into radio astronomy, I'd recommend, and if you live around the East Coast, West Virginia there, I recommend getting over there and checking it out. Or if not, just look up Sarah. Basically, I typed in S-A-R-A, and then I added radio to it, and it came up with what it is. So our group at the observatory has done a little bit of radio astronomy. They've done a couple things. We got a what size? Oh, we built a horn. Oh, the other guys had built a horn antenna.
Yeah.
Basically, kind of like a pyramid out of sheet metal, and put a radio receiver up right inside the point there, and it will actually pick up hydrogen in the Milky Way. We could definitely see a peak in the reception at that frequency as we're scanning around. So, and we also have like an 8-foot radio dish, and setting it up for trying to find a pulsar. I think we've got the sun so far, but we're going to be trying for a pulsar and see if we can detect that. Unfortunately, a lot of trees kind of get in the way of the observation, so got to time it so it's in between the trees. So.
It's nice to see that Sarah was at the Dayton Ham Convention this year, as well as the Orlando one, because it's kind of ironic that some of the people I talked to back home, I said, well, when I start talking about having the observatory on the air, I start getting little titters of laughter. He says, well, I suppose we really should be doing that too, but we can't, because if we're on 2 meters near the dish, we would be kind of interfering with a lot of the observational work. But as I say, a lot of radio astronomers are radio amateurs as well, and I kind of like how these hobbies blend nicely.
Indeed. One thing I had for us here is you're listening to astronomy.fm radio. It's radio astronomy, not astronomy. No, it's astronomy radio, not radio astronomy. I got to get it right. I can't say it too fast. I have to read it.
Okay. Now, scientists have discovered a new type of pulsating star.
They have.
They have, yes. The nebula remains of a giant star surround the remaining subdwarf. Okay, so let me just pull this up. It's a subdwarf O star, and it's a new, from what I understand, it's a new kind of hot subdwarf. So let me come out. I'll put the picture into chat.
But from what I understand, it's not a white dwarf.
Not a white dwarf, no.
But kind of like a white dwarf, but not a white dwarf. It's small, super hot. Yeah. Surface temperature of about 90,000 degrees Fahrenheit. But has a little different way of forming, and there's some interesting features about it too, like whether it has hydrogen or say helium in it or not helium. And
of course, the really interesting thing is this new class of pulsars, they vary in brightness every 5 minutes.
Mm-hmm.
So the results of the paper actually appears in the Astrophysical Journal Letters. Many stars pulsate, even our sun does on a small scale. Now, a true pulsator can vary in brightness by about 10% due to a periodic change in its temperature, radius, or both. Those with the largest brightness changes are usually radial pulsars, breathing in and out as the entire star changes size. So by studying the pulsations in detail, we can actually learn about the properties of the star's interior. Yes, Glenn, there is a black hole at the center of our galaxy. It's called Sagittarius A. And I just want to welcome Asgia581 to the chat room. We are live tonight. We have links coming in. There will be links with the YouTube video once I get that up, probably tomorrow morning. So you can always catch up with what we've been talking about and what we're reading.
And we repeat this show every 4 hours for the next 24 hours.
Absolutely, that we do.
Catch us right here on astronomy.fm 3 hours from now. And a little more.
So, where are we time? Oh, we got 20 minutes yet.
We got time.
Well, you know what? It's the event horizon. So guess what we're going to do? We're going to have a black hole story.
There you go. You got a black hole story this time?
I got a black hole story, yeah.
All right, let's go for it.
In fact, Black Projects has put a radioactive brown dwarfs or a new class of pulsar story in as well. We'll have a look at that in a few seconds. So, goodbye Big Bang, hollow black hole. And this is supposedly a new theory of the universe's creation. This is actually a story back from September the 19th, 2013. And they are saying that the Big Bang theory could need a revision. A group of theoretical physicists suppose that the birth of the universe could have happened after a four-dimensional star collapsed into a black hole and ejected debris. But before we get into their findings, let's just preface this by saying nobody knows anything for sure. Humans weren't around. It's speculation. Exactly. The standard theory. Yeah. Back to event one, yes. Event one. The Big Bang. Anyway, yeah, so the standard theory is that the universe grew from an infinitely dense single point, or a dense point or singularity. But who knows what was there before? As they joke, they say, for all physicists know, dragons could have come flying out of the singularity. This was from Nayesh. No, you never know. Anyway, so this was from Nayesh Ashfordi, an astrophysicist with the Premier Institute for Theoretical Physics in Canada, who co-authored the new study. So, what are the limitations of the Big Bang? Well, the singularity is one of them. It's hard to predict why it would have produced a universe that has an almost uniform temperature. The age of our universe right now is about 13.8 billion years. Doesn't give it enough time, as far as we can tell, to reach a temperature equilibrium. And Redshirt 3 is answering a question in the chat room. What is the width in light years of the Milky Way? About 150 light years, give or take, the diameter of the Milky Way. Thank you, Redshirt 3. Anyway, so the universe must have been expanding faster than the speed of light for this to happen, but that theory has problems. The Big Bang was so chaotic, it's not clear that there would have been even a small homogeneous patch for inflation to start working on. So here is actually a representation of the timeline of the universe, and I'll stick that into the link in there. So this is what the physicists are proposing. It's a three-dimensional universe floating as a membrane or brain in a bulk universe that has 4 dimensions. Yeah, it's kind of making my head hurt too, but it might be easier temporarily to think of the brain as 2-dimensional and the bulk universe as 3-dimensional when trying to picture it.
Or 4-dimensional and brain's 3.
Yeah, let's not go there, because this is mind-blowing enough. It's almost as mind-blowing as a Babel fish on a Vogon constructor ship. Waiting for comments. None. Okay. There is more technical details in this 2000 paper on which the new theory is based. Well, so if this bulk universe has four-dimensional stars, these stars could go through the same life cycles as three-dimensional ones we're familiar with. The most massive ones will explode as supernovae, shed their skin, and perhaps have the innermost parts collapse as black holes. The 4D black hole would have an event horizon, just like the 3D ones we're familiar with. The event horizon is obviously the boundary between the inside and the outside of a black hole. A lot of theories about what goes on inside there. No one has ever observed it because no one's ever returned. In a 3D universe, the event horizon appears as a two-dimensional surface. So in a 4D universe, the event horizon will be a 3D object called a hypersphere. So what they're saying is the 4D star blows apart. The leftover material would create a 3D brain surrounding a 3D event horizon and then expand. The long and short of it, well, to bring us back to things that we can see, it's clear from observations that the universe is expanding, and it's getting faster as it expands. This is put down to dark energy. The new theory says that the expansion comes from this 3D brain's growth, but there is at least one limitation, obviously. While the model does explain why the universe has nearly uniform temperature, the 4D universe preceding would have existed for even longer. A European Space Agency telescope called Planck recently mapped small temperature variations in the cosmic microwave background. Now, if you remember back to the old analog TV sets when we all had over-the-air aerials, and sometimes when the station shut down for the night, you got static. So that is one way of actually seeing the cosmic microwave background. So that gives you an idea. The new model differs from CMB readings by about 4%, so they're still having to work on the model. They think it has worth. However, Planck shows that inflation is happening, but it doesn't show why the inflation is happening. The study could help show inflation is triggered by the motion of the universe through a higher dimensional reality, they think. You can read about this in the pre-published AVRXIV paper. It does not specify if the paper has been submitted to any peer-reviewed journals for publication. So if you're really into it and you want a really good bedtime read, there you go.
Yes,
and of course, there's some cracking good links in the chat room.
If you want to get a good sleep, read a physics book.
Funny thing is, that's how I used to put myself to sleep some nights. If I really couldn't get there, I would get something really, really mind-bogglingly complex. One of the books I used to go for was Susskind's Holographic Universe. If you've ever read the book, you will know that it is 90% mathematics. I actually lent it to Starstorm at one point, and she couldn't read it. Yes, I did. I think you took it to school with you one time. Oh, that was Bang. Okay. But anyway, there's a lot of good links in the chat room. And Redshirt 3 saying he was wrong. It's only 110 light years in diameter. Interesting.
There you go.
Hopefully Starstorm will have captured some of those extra links, if possible, please. But this is the great thing about being around for the live show. You get to see the links that are in the chat room, not only the links that Marty and I put in, but the links that everybody else is putting in. And this, to me, and I'm sure Marty agrees, this is what makes the show tick, really.
And if there's links that I don't put in and you don't put in, nobody puts in, those are the missing links.
Yes, they are.
There you go.
But,
coming up on Tuesday, there will be the release of the Northrop Grumman Cygnus NG-11 cargo craft from the International Space Station. And Monday the 19th, Astronauts Nick Hague and Drew Morgan will spacewalk to install a docking adapter at the space station. So that's what's happening with the International Space Station.
Which is due supposed to be next year, supposed to be boosted to a higher orbit.
Is it?
Supposedly. Well, there's talk about it going to a higher orbit to take it out of the garbage that floats around in low Earth orbit.
Oh, that would be good then.
It would be good, but they are really going to need to have better, more effective rockets to get there. They're going to need things like Orion, Starhopper, etc. And they're going and that really freaking big rocket that Musk is promising us.
The BFR.
As Starstorm points out, he's making more progress than other people. It's interesting that private enterprise seems to be leading the way, which is kind of a good thing in some respects. Space travel is an expensive business. It takes a lot of GDP and investment, and if individual companies are prepared to put the investment in, like SpaceX, like Wild Blue Yonder are, which is owned by Steve Bezos of Amazon. I think basically, really, Starstorm, everybody's having their setbacks, but whether or not they actually become a major setback, I think, is for the private companies. It's not going to happen because it's going to cost too much money if it happens. They have to keep pushing forward, and try and meet deadlines as much as possible. It's always been the problem with government-funded missions. Things can slip. They can slip. Accidents happen in test and transport, and things get put back. Orion is an example. SLS is an example. Yes, things do happen on the launch pad too. We'll remember Apollo 1. Some of us remember Apollo 1. There's Challenger. Space travel is not. If you want to avoid risk, don't go into space travel. It's probably a very risky business, but it has great rewards to those who are prepared to reap them. And at the end of the day, who dares wins, he says. And nobody's commenting. But anyway, James Webb is supposed to launch finally, hopefully, next year. Its Ariane launcher is sitting there waiting for it. It's so heavy that there is no American launcher that can actually launch the James Webb Space Telescope. And of course, the nice thing is, it is going to be one of these telescopes that's going to start looking back towards Planck time itself. And who knows which theory may now survive. Yes, Marty.
So we got of course, a quite famous meteor shower coming up.
Yeah.
About a week and a half or so. The Perseid meteor shower going to happen around the 12th to the 13th. Unfortunately, the full moon will be kind of getting in the way of that. But a lot of the Perseids are so bright, full moon won't make a difference. So basically, you can kind of turn your back to the moon, or use a baseball cap, kind of look underneath the moon, look around it, and hopefully you'll see some nice bright fireballs for that one. Perseid meteor shower. Of course, that was from the passing of comet Swift-Tuttle.
Yeah. That's
been making quite a few orbits. I think it does an orbit every 133 years, something like that. Last time it came around was in 1992, but it is the source of the Perseid meteor shower.
133 years.
133 years, yes, for it to go around once.
It fits the classical definition of a Halley-type comet with a period between 20 to 200 years.
Mm-hmm.
Last perihelion was December the 11th, 1992.
Yep.
And it was discovered independently by Lewis Swift on July 16th, 1862, and Horace Parnell Tuttle on July the 19th of the same year. It has a radius of about 13 kilometers. As you pointed out, it spawned the Perseids. And did you know that the comet Swift-Tuttle stretches more than 16 miles wide?
Yes, it's really
roughly
big.
Equal to the object that wiped out the dinosaurs.
Yes, it's a big one, really big one, and it's an Earth orbit crosser, or pretty close to it.
Well, we're glad that you're enjoying this 2 Asjet 581. We do our best to entertain and inform, as I'm told by Starstorm.
Some nights goes more one way than the other, but okay.
Well, as I say, you can explain more with a wee bit of comedy and a bit of fun and games.
Otherwise, we would just be reading off lists of things. That gets kind of boring.
Basically, we're doing the shipping forecast for planets, asteroids, and moons.
We like to let people know what's happening in the skies and keep it from getting bored. I try to make it especially a little lighthearted.
Now, that's interesting.
Keeping it light, like Saturn is lighter than water.
Yeah, Saturn would actually float in your bath if it could fit in it.
Yeah, it's so light. Go ahead. You know that one? It's so light. If you had a giant bathtub, Saturn would actually float in it. And if you took Saturn out, it would leave a ring. That's the story.
Is it a rock ring or an ice ring that it would leave?
Just a bathtub ring. Oh, a star that is orbiting around a planet called WASP 121b. Basically, when a planet goes in front of a star, starlight dips down, and by the amount of dipping and the timing, they can determine that it's actually a planet going around the star. And they can also determine a few other things, like how close it is and how big it is, by the amount of dipping compared to the size of the star and stuff like that. And what they really ultimately want to look at is when the planet goes in front of the sun, seeing the star's spectrum changing and detecting other elements that are not normally in the star, so they must be coming from the atmosphere of the planet itself. So looking for things that would be helpful for life, like water vapor, oxygen, nitrogen, things like that, methane, all gives a potential for some life. But we know that some planets orbit so close to their parent stars that they are superheated. And this is one of those. It's a giant planet in the Jupiter-sized category, basically a giant ball of gas. It's so close to its parent star that it's actually deformed. So the star is kind of tugging on it, and they are detecting gases coming off the star, but metals, called heavy metals, like iron and magnesium. So, yeah, this one has an iron and magnesium atmosphere because it's so close to the star. The atmosphere is heated up to, like 4,000 degrees, something like that. So quite a hot place to be. It's about 900 years away from the Earth. 900 light years away from the Earth, by the way.
Now,
that one in the chat room.
Yeah. The other thing, whilst Marty was talking about that, I happened to come across a link. Again, it's going back to Swift-Tuttle. It's a little bit alarmist. I haven't had a chance really to. I just think I read who's the author on this. Robbie Berman. Okay, so there's a radio astronomer believes that Swift-Tuttle could be a danger to life on Earth. Having said that, reading through the article quickly, as I was, it comes back every 133 years. It sheds debris of ice and rock. It's estimated to grow as wide as 10 million miles, a length of more than 75 million miles. It rains down on us on an average of 37 miles per hour. Each August we call them fireballs, we call them meteors. It's coming in faster because it's an elongated orbit. So that's why this particular show is always a little bit more spectacular because of the speed. What concerns some scientists is that every time it passes the Earth, it's slightly closer. That's not much changed year to year, but over time it adds up. In 92, it was 10 million miles away, but they think by 2126 it'll be at 14.2.
There's only one way. There's only one way to save us, Nick. Beam us out of here.
Yeah.
It's time, everybody. Thanks for everybody listening in tonight. See you all again next week. Good night.
Chief Engineer Rob, the away team of myself, Starstorm and Marty is ready to beam up. Energize.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.fm. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.fm. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.fm Radio.
Hi, this is Tavi Greiner, Astronomy.fm's Vice President of Communications. If you enjoy our programming, please let us know with a donation to astronomy.fm/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM. There I was, doing my thing, and all of a sudden, wham! Astronomy right between the eyes.